Kate Meredith here, your parking lot scientist, here to help you with the next phase of the Global Systems Science sampling carbon dioxide investigation. And in this installment, we are going to look at some of the problems associated with using a car to blow up a balloon. Now, in this investigation, being the good scientist that I am, I'm looking for all possible sorts of error that could happen. And we want to keep all of the variables the same in this. We don't want to change anything except the source of the carbon dioxide. So what I about is how to get the exhaust from the car into the balloon. And so for this purpose, you're going to make a funnel. And the thing I found out about when I started working on this is don't use anything flimsier than a file folder. So I used an old file folder, just wrapped it up and then twisted it into a cone shape. Use your favorite color duct tape to make it nice and secure, and make sure that your opening is at least a couple of centimeters, between a centimeter and 2 centimeters in diameter. And that should give you just enough to easily get your balloon over the end. Now the next problem I ran into is when I went to blow up the balloon, I turned on the van, got the cone securely over the end with the balloon on that, and nothing happened. The balloon puffed up a little on the end, and pretty soon, if I made the seal nice and tight, the car idled down to practically nothing. Now, knowing that this couldn't possibly be a good thing, I turned off the car and sat down and thought about what I needed to do. What I decided was that the balloon was a little bit too strong. I brought good quality balloons so that they'd all be consistent elasticity, because I want to reduce my sources of error, so I want all my balloons to be exactly the same. But I don't want them to be so good that I can't get them blown up with a car. So the next thing I decided to do was that this balloon would have to be blown up and weakened a little bit. So I blew it up nice and big, once, twice, 3 times did the trick. And with that, you'll have to experiment around and see how much you have to stretch your balloon and weaken it a little bit so that your car has enough power to blow it up. Now, one of the things you want to remember is that if you're using an elderly car with an elderly system, my local mechanic informed me that idling it down is letting me know that the pressure is building up, and if you have a bad muffler, that could cause you some problems in your muffler system. Now remember, in any experiment, you got to control your sources of error. We only want one thing to change in this experiment, and that's our source of carbon dioxide. It's going to come from our breath, from our classroom air, or from the car. And we don't want anything else to change. Now, I already told you, I blew up this balloon 3 times to weaken it enough so I can get the old van here to blow it up. But that introduces a source of error. So you're going to have to make sure that however many times you blow up the one balloon to get the exhaust from the car into the balloon, you're going to have to do the same thing for the balloons that you use in your classroom. The other thing I want to talk about is why that's such a big issue. Well, behind me I have my favorite mode of transportation, my recumbent bicycle. And in each one of these 2 very different size wheels, these tires, I have 100 pounds of pressure. And according to Boyle's law and Charles' law, and I'm going to save the details of that for your chemistry teacher, that if I have the same volume under the same pressure, I'm going to have the same amount of gas. Now remember, we want to keep everything the same. So one of the things we want to keep equal through the entire experiment is the amount of gas that we use to test our carbon dioxide. That means that the balloons have to be under the same pressure. So just like these tires have different diameters, they have different volumes, the pressure's the same, but the volume's different, the actual space inside. So I know that's not the same amount of gas. But I could have 2 balloons that I measure the diameter with and have the same diameter, they have the same volume, but if I have one of these balloons that I stretched and weakened, it doesn't have the same pressure to it. And because of that, good old Boyle and Charles say it's going to have a different amount of gas in it. So be sure that when you blow up your balloons, they have the same elasticity. Now the moment you've all been waiting for. We've got our funnel, we've got our balloon that we've weakened just a little bit, and now we've got our running vehicle, and we're ready to blow up the balloon. But the good scientist in me said, there's a lot of air in here that's not exhaust. That's not so good. That's a source of air that I would like to get rid of. Well, after having played around with this, I've decided there's a certain amount of air we're going to have to make a note of. And in our report, we're going to have to talk about that's a possible source of air. The best that I can do is put the cone up to the exhaust and just leave it there for a second and try and force some of the air out. And now when I'm pretty sure that I'm doing well here, I'm going to just put this funnel right up nice and secure, hang on to the balloon, and voila, we have our balloon blowing up. Now before my car idles down too much, I want to pinch off the end, take it off, and there I have it. Now, hopefully, you're going to take a look at this and you're going to have your string here available, and whatever size you manage to blow your balloon up in the part of the experiment where we produce carbon dioxide from vinegar and baking soda, you want to make this the same size. Take your twist tie, tie it off, and transport it to the classroom. This is probably the last step that you want to do because you don't want this sitting around in here too long, because there's a few other volatile gases in here that don't get along too well with the latex in the balloon. See you in the classroom.